Hey everybody, Mr. G here. Let's talk about the basics of functions. I'm going to pull up my preview here. So oftentimes in programming, when we want to do something multiple times, we've recently defined loops, which allow us to do things a bunch of times or repeat instructions. But there are situations that come up quite frequently where maybe we want to do something multiple times, but it's sparse. It happens occasionally at different points in the program where a loop would be a little less helpful for us. So to help repeat actions at different point in a program, we have functions. As usual, there's a functions.py file to go with this that has all the examples from this. And there's also a classwork that has some examples from this, the answers to which are in work completed. And there's also homework, which goes back to this a little bit, whose answers are also in work completed. So let's take a look at functions here. So first of all, we have the keyword def, which is short for definition or define. So I have it bolded here. So we use def to help Python understand we're creating a function, and we need to give functions a name. So to choose a name for a function, it's very similar to naming a variable. So you want it to be a little bit descriptive of what the function is going to do, but not really, really long or complex that would make it difficult to write when you need it. So I have a really simple basic definition of a function here. So I wrote def, and then I wrote a function name. In this case, I wrote print HW, where HW stands for hello world. And then I have parentheses, and it's important here that the parentheses are here, because that tells Python that what we're using is a function to be called. And then we have a colon, which we're starting to get more familiar with as it pops up in conditionals, in loops. It comes up quite frequently. And then inside of here is the action that will happen when the function is called. So one important thing is when you define a function like this, even though there's a print statement, this print statement isn't executed at runtime. So if you just had a program with this in it, just this definition, and you ran it, there wouldn't be an output. In order to get an output, we need to call the function. So on any line after you've made this function, you can call it just by using its name with the parentheses. So just a line that says print HW, which normally would mean absolutely nothing, it goes up to this and says, oh, I know what to do in this situation. I print hello world. Now this function isn't particularly useful because we don't need to print hello world very many times, but it gets the basic point across about how we define a function, what the action looks like, and how we can call it to execute its information. Now, to make functions more useful, we have parameters and arguments. So just like a function in math takes in an input, we can make functions in Python take an input. When we define a function, or when we are defining a function, we call the input a parameter. And when we actually call the function with the input, we call it an argument. So we'll end up using parameter and argument a little bit interchangeably here. To give a function a parameter when we define it, we create a variable inside the parentheses. It's going to be a temporary variable. It only exists while the function is doing its thing, but we name it inside of here. So I made a basic function with a parameter. I called it hello, and it's just going to greet whatever name we pass into the function. So if you have to say hello to multiple people, this would maybe be a little more useful. So in this case, it's going to take an argument that it's going to translate to be the variable name, and we'll pass it into our f string here when needed. Importantly, once we start incorporating parameters like this name here, we can no longer call the function with blank parentheses. The blank parentheses would cause an error. So if you typed in hello with blank parentheses here, when we clearly define it with a parameter, you would get a type error. It would say, oh, you're missing an argument. You were supposed to give us a name. It works fine as long as we pass in a value. So inside the parentheses here, I put a string. It's my name, John. And it produced the output, hello, John. Now, one parameter is great, but sometimes we want to give it more than one piece of information at a time. You could give a function as many pieces of information as you like, using a comma to separate the names of them. So here's a function with multiple parameters. I gave it the same name, but this time we have two parameters, name1, comma, name2. And we define it to print one string that says hello first name and hello second name. So we can call this function by passing in two values separated by a comma. And this works with any function. It could be a variable or it could be hard coded. So I actually show both here. I make a variable that has Nathan saved into it, and I hard code Cody into the function call here. So I pass in a string in a variable via Nathan and a string literal here in the middle with Cody. And it produces the output, hello, Nathan and Cody. Now, when we do something like this, it temporarily makes a copy of the information in name and puts it in its temporary variable, name1, to use it. We can use iterables too. Iterables are really powerful. They allow us to work with multiple objects at once. And so a function could take in anything, int, float, bool. We've already shown it with strings, but it could also take in an iterable. So the cool thing about passing in an iterable is it doesn't look any different from a normal parameter. So here I have def hellos names. And besides maybe the hint that we're going to have multiples here, because I used a plural, there's really no difference in this definition. And then in here, I actually just use a loop. So I say for each name in this names iterable that was passed in, print hello that name. And it'll go through and print as many times as needed to cover all the names in the iterable passed in. So I make a tuple here with Rihanna, Nafisa, Christina, and Danae. And we call hellos on that tuple. And we see it print out each of those names, a greeting, on different lines. So it goes through each of them and prints them. We do have to be a little bit careful here. When we expect a function to have an iterable as an argument, if we just passed in a single name instead of a bunch of names, we get behavior that's maybe a little less desirable. So here, if I put in Madeline as a single name, it doesn't give me an error because Python doesn't necessarily require that this needs to be an iterable, but it treats the string as an iterable and splits it up into its component pieces. It splits up all the letters of Madeline, so it kind of spells it vertically here, but these hellos are kind of useless. Now, finally, the last thing we're going to talk about is we have default values. We saw earlier, once we start using parameters, we can't just call the function with blank parentheses anymore. Default values are a way to prevent that from being a problem. So we can tell a function to use a default value for one of its parameters if it's not given one. And we do that by setting the variable equal to some value in the definition. So we see up here def hi, and I say name equals world. So this means that if you're given information for a name, you use it, but if you're not given information for a name, you use world in its place. So, and then we print hello and whatever the value of name is, whether it was information they gave us or whether it's the world we use as default. So now we can print a greeting regardless. So I say hi Josiah prints hello Josiah, and hi with blank parentheses prints hello world. It utilizes that default value and no longer gives us an error. Now these functions have all been really useful, but we're missing a really key aspect here, which is the return keyword. So in the next video, we're going to talk through how return works and what it offers us in terms of functionality.